Good morning, everybody. Welcome back to lecture number
26.
So in the past week and this week, we have been talking about operational amplifier, right? We did go over multiple concepts, starting from an ideal op-amp, inverting amplifier and non-inverting amplifier. What's the key common information about inverting, non-inverting?
Positive or negative?
Negative feedback. Forget about inverting and inverting. Like, I know when inverting goes to the negative input, the other goes to the positive, but the key important information for circuit analysis is what? The summing point constraints. Summing point constraints is the most important thing, which does not exist in the positive feedback circuit. But before we go to the slide, let's have a look about the old exams, okay? Just have a look. I'm not going to solve it, okay? The reason I want to is just to show you how probably last semester, so for example, what was last semester, 241?
Yes.
So this was 241, for example. It was all MCQ. Who complained that we have MCQ? Last semester they had MCQ for Major 2. Up until now, we haven't decided whether it's MCQ or written. But trust me, if it's written, أول ما تفتح الاختبار, you might spend the first 5 minutes just thinking, how does it feel? Not a good feeling. And many people end up writing nothing. So my approach, and I'm not, Dr. Atiyah is the coordinator, my approach is to have as much small problems as possible. But it has to be MCQ. Why MCQ? Because if you know it, you get it. You don't know it, you don't get it. بس إذا حطينا أسئلة مقالية, usually the healthy practice is each problem graded by one professor. If it's graded by 3 professors, how many professors you have to chase? 3 professors if you want to review your exam. It's a tough task for the student, for the faculty member. There is more than 100 students taking this course. So it's a big course, okay? I know in mechanical engineering they have what we call it written problems. But trust me, I would rather have smaller problems to handle and then sacrifice 2 or 3 problems than having one giant problem that I waste 10 minutes of the exam, know nothing about how to solve. So look at this exam. Now, looking at this problem, what chapter? Chapter 5. No, chapter 5. Because we have omega, we have to convert 10 microfarad to 1 over j omega c. And then we use our favorite rule, CDR. Once you get the CDR, you can calculate the complex power. Once you calculate the complex power, for example, you get like S equal what? 1 over 2 V I conjugate, then you can calculate Q. Okay? Look at this problem. Chapter 5. Find the power factor seen by the source and state whether it's leading or lagging. It means you have to find the current. Once you find the current, the angle between the voltage and the current gives you the power factor. And which one is leading, which one is lagging, you have to plot it, okay? This problem, we did it in the slides. It's chapter what? 5. What about this problem?
1.
Chapter 5. This is also chapter 5, Norton and Thevenin. We did this problem in class, right? Similar, but change numbers. And then also maximum power transfer. You remember the maximum power transfer? Z conjugate. If you only allowed to use resistive circuits, you take the absolute value of Z conjugate. So how many problems? 6 problems. Happen. Where have you been the past 3 days?
Sorry,
Huh? Did you watch the YouTube?
yes.
As long as you watch the YouTube, I'm happy. So 6 problems from chapter 5, then he started bringing chapter 7. Now I think in 241, they had major 1 covering chapter 3. Okay, they had major 1 a bit late. Bunassar, please, if you're not happy, can take a break at home. Now, this is easy problem, okay? We all now know this. What is this op-amp? Inverting input, negative feedback, classical inverting amplifier, right?
Yes.
Because it's a classical inverting amplifier. Here, the only thing he wants you to know is he gave you the input as a sinusoid. And, you can convert it to cosine, but he didn't convert the answers to cosine. So, you just need to multiply it by the gain. So the only thing that changes is the amplitude. Get it? Get it? Okay. Now he started playing games, okay?
Started to open. He started with open. Come on.
But let me ask you, is this inverting or non-inverting, or it doesn't have an input?
Non-inverting.
It does not have an input.
Voltage. There's no voltage.
No voltage.
No, there is voltage. Supply hidden. But this circuit, it doesn't have an input. Hatem, do you see V input?
No.
Okay. Here, do you see V input?
Yes.
Yes.
Yeah, this is V input. But here, do we have V input?
No.
So it means you can treat those two as provided signals. Okay? Does it have a negative feedback?
Yes.
Why it is important to verify there is a negative feedback is because to
Summing point constraint.
summing point constraint. So if this is a 3.3 volt, what's the voltage drop here?
3.3.
What's the voltage drop at the current source?
3.3.
3.3. Now, it is an easy problem. You do not have to use it here, but also you need to know the 2 milliamp will flow here. Okay? So once you know the 2 amp is flowing here, you can calculate V output to be
V output.
the V voltage drop here minus the 3.3. So to calculate the current, you already know the current is 2 milliamp. It's going to swim here. It does not going to swim inside. So V output plus some minus, this is plus voltage rise, 3K times 2 milli, which is 6 volts. And then here, plus minus 3.3, which is going to be minus 3.3. And calculate the answer. What is the answer? So do you see how I want you to think? Did you get the calculations right for this problem? What's the gain? 6 over 3, so it's minus 3 times 2 is minus 0.6. But keep in mind, what happened? So this is in volts. Okay. رجع يدخن ها؟ يدخن في نهار رمضان. No, but do you smell this? No. No, these comes from the restaurant. في restaurants في الدور الأول. مستعان بيفطرنا معاه. Anyway. Why this number is correct? I really don't know. Anybody can analyze? Oh, the question is not find V output, find the gain. Find IL. So IL is what? V output, which is minus 6 over 10K, which is minus 0.6. Always read the question. Reading the question is 30% of the answer in EE. Okay? Let's look at this problem. This is a tough problem. Do we have an input? Hatem, do we have an input?
Yes.
No, do we have V input?
No.
Okay, we don't have a V input. هو دخن برضه الأسبوع اللي فات؟ احنا صايمين ما انتبهنا. اوكي. ها؟ اوكي. راح بالي. Okay. So here, do we have a negative feedback?
Yes.
Yes. So voltage summing constraint exists here. So what's the voltage drop here? 2.2. Here plus minus 2.2, but here plus minus. So they will cancel. So this will be 1.1. And then you have to calculate the current. I leave it for you. I don't want to burn the problem. So look at this problem. Find the output. Okay.
0.
Wait, why did you say 0 like that? لأنه إيش? Well, let's do the analysis. We have here, we don't have the input, but we have a voltage source and a current source. So negative feedback, yeah. So what's the voltage drop here? Oh, the 1 milliamp will go here. So the voltage drop here is what?
3.
3. So we see here what? 3. Okay? We see here what? 3. So 4 minus 3 is 1 volt over 2, which is half kilo amp. And then another half kilo amp will go there. The question is, find the output.
You calculate the current using the node analysis.
Okay, if we do it, what's the current now? 4 minus 3 is half. So what's the output? It is, the output is what? Plus 3, plus 1, minus 4. It's what? 0. Jihad, did you get it? That's how we should solve it. Many students who did not study hard for the quiz next week, they will say, oh, 0, there must be a trick. What's the trick? Oh, because it's open circuit. خلاص, the open circuit معناتها 0. No, ما تمشي الأمور كده. You have to do the analysis. Okay? I criticize this question because this question is not a nice question. Why you give an output 0? To confuse the student? I leave it up to you. Inshallah, we will not have these things. We want to have more practical, useful information for the rest of your life. But do you see why it's 4? This is minus 4. Minus 4 plus 4 is what? Plus 4 minus 4 is what? 0. Did you get it? Okay, try to solve this. Find the value of, okay, this is a 2-stage amplifier. I'm not going to solve it now, but here it gets where we have we have inverting, we have non-inverting, and he's connecting 2R here. This was, I think, a tough problem for the major 2 over there. Okay? And then here he talks about diodes. Mishal Kusam. You missed 5 old exam problems. Nakhli, what happened? Why did you come late together? We'll find the deal, okay? Office hour, برضو? Was he with you? Okay. Did you see how many problems for the op-amp? 12. No. 1, 2, 3, 4, 5, 6, 7. So if you study chapter 5 and you study chapter 7, guaranteed 14 problems in the test. Right? And then with chapter 3, maybe we'll have 3 problems. We will try, I'll try. Do you want to have 20 questions or 20 or 30?
20.
You want to have 30?
20.
You want to have 20? Tell me, how much you want? I can push for 20, so each problem is 1 point.
30 يكون سهل.
What about if we make it 30 and we increase the time by 1 hour?
يكون سهل. مو معقول.
It is what it is. So did you get a flavor of the old exams? You want to have another flavor? Let's do 2, 3, 2. When it was a midterm. I don't like midterms. Imagine doing this time with Imagine. Astaghfirullah. Okay.
You will have the final.
Yeah, but no, not really. Final exams are usually designed to be generic. Chapter what? 3. And clearly it's a CDR, or capacitor current divider rule. Here we have equivalent. And then here they have the written parts, the written questions, which you always like, okay? So students love these questions. And you can see how they distribute grades 0.1, 1, 1.5. It is very hard. لما يجيك واحد زي مشعل يحط لي mesh analysis هنا, it's very hard to tell how much we redistributed. Get it? The problem is asking for equivalent impedance, or this problem, write nodal equations, and then someone doesn't read the question, start doing mesh, complaining that y got 0, and he lost half of the, or 25% of the test. That's why I do not like written problems. I don't want, my argument is against the written. I don't know about Dr. Atiyah. Dr. Atiyah قرر خلاص.
But so is it possible to be fixed?
I don't like it, يا أخي.
I know, but is it possible?
Of course, it's either mixed or all MCQ. There has to be MCQs. بس أنا عشان مصلحتكم ال MCQ, the more you have, it's better. غط الخيارات وحل المسألة. غط الخيارات وحل المسألة. إذا ما عرفت تحلها, guess. But if you write down the answer, بعدين يجيك مثلا والله افرض طاح سؤالك عند الدكتور مثلا, I'm not gonna mention names, وعطاك يعني very aggressive grading, بتقعد تقول مين كتب السؤال, مين صحح السؤال. That's fine. Again, do we have op-amps here? No, they didn't include op-amps in the midterm. Let's look at this major 2. Okay. This was 231. Okay, what chapter is that? 3. What chapter is that?
3.
What chapter is that?
3.
And here,
5.
started doing 5. This is Fazer's problem. Who's leading, V1 or V2?
V1.
V1, okay. What chapter is that? 5, RMS. You have to do the integration. Root mean square value. What chapter is that?
5.
Can you zoom in?
Can you do it by calculator?
Yes.
Okay, do it now by calculator.
We cannot see it.
This is, I need to download it. Can you see it now? If you can't see, you can walk. But don't touch the table. Well, if you can't see, you should sit at the front, yeah.
أظن الدكتور الآن بلس حركت.
Well, it is 100 angle 45 plus 100 angle 60 minus 30, which is minus 30. Add them together, what's VS?
It is 158, angle 7.5.
Plus or minus?
Plus.
So it's C, so 6C, it's C. 6C, you got it right.
Yes.
Okay? Okay. What chapter is this? By looking. The input impedance.
5.
Chapter 5. Okay, you have to get... well, this is a tricky question. He's giving you... he's giving you the Z. He wants back the omega. Okay? So the way to do it is you have to say minus J 1.1 is the parallel combination between those two impedances. And you have to solve for omega, and once you get omega, you should calculate F. This is a bit tricky problem. How about this problem?
What?
Chapter 5, of course, but this was nodal or mesh or what? Probably mesh.
Mesh, yes.
Mesh is better, huh?
Yes.
Can you say source transformation?
Not really. Not source transformation. Source transformation if you have 3 or 4 loops. You can do source transformation. If you do source transformation, this will be voltage source and the right way, or can you do nodal? You can do nodal. Do you need Carter's rule? No, you do not need Carter's rule. If we do nodal, it will be V1 minus Vs phasor minus Is plus V output over 10. And you solve for V output. This is a lovely question, by the way. Very good. Hatem, you have to solve this, okay? It's a very good question. Because in Carter's rule, it may not come in the test because it's too long. Okay? Now, if you want to have written question, we'll bring Carter's rule. I don't know yet. What chapter is this? 5. CDR, صح? You have IS, you use CDR.
Calculate the impedance.
Yeah, of course. We are professionals. We have to convert everything. What's omega? 200. Okay? Again, maximum power. So what is ZL? You have to find Z definite conjugate. Z definite conjugate is 325 in parallel with J700. Get it? Find its conjugate. It's ZL. That's an easy problem. We did this in the class. Your favorite thing, op amps. Now,
So which is hard? 3 or 7?
the hardest is this 7. That's why we're spending more time on it. This is a hard problem or easy problem. Well, for VA, we know it's minus R3 over R1. So we can eliminate option A. We can eliminate option E. So it's either B or C or D. But how about this?
Can we just find the voltage of the first?
Well, keep in mind that, do we have a negative feedback?
Yes.
Okay, what's our lovely point from negative feedback? Summing point constraint. So, summing point constraint, this means the voltage here is what? 0. Because the voltage here is 0, this is like what? A ground. Okay? This acts, this is a ground here, this is a ground, this is ground, this is ground. Okay? Now, what is the input here? Now, I have here, think of the VB, R2, R4, all as one circuit. Okay? What is the voltage here? It's R4. So we apply VB, right? What is V input here? What is the voltage that appears here? It's 0 volts, صح?
Yes.
So this means, what's the input impedance? In classical inverting amplifier, this looks like a summing problem, صح? But this summer is not classical connected. There is 2 resistors here. Because of that, you have to find R4 parallel with R2, and the equivalent one is inverting amplifier with R3. So I don't know what's the answer. Can you guys calculate it? Should we try to do it? Maybe. What is R4? 1 over R4 plus 1 over R2 inverse. It's going to be what? R2 plus R4 over R2 R4.
The reciprocal, right?
Yeah. Times 4. Late. Or should we use VDR?
VDR.
Why VDR?
I don't.
The problem here is you have a ground here. So if you have a ground here, and you have a ground here, no current will flow with R4. So my guess, I haven't solved it, and I will not. My guess is what? Maybe R4 we need to ignore it. Maybe it's just R2, so it's maybe minus R3 over R2. I don't know. Is it option D? 13? Go back.
I think B.
Let's see, I don't know, I could be wrong. What is 13?
13
It's
D.
option D. Okay?
So,
Trust yourself always, ya shabab. So did you see? So R4 was what?
no.
This was useless. Why? Because R4 was grounded from the two sides. If you ground the resistor from both sides, it's useless, okay? Do you guys like this session? It's like a help session, صح?
Yes.
Today, what is today?
Tuesday.
Okay, so on Thursday, we will make the lecture. We will continue doing revision today. I think we need to do revision. I want you guys to be strong. YouTube. Watch this twice, okay? Okay, so we did solve this problem, okay? How about this? I think we did solve this problem last class. Do you remember? It has R1, R2, R1, R2. Do you remember on the slide? Hassan, did you watch last lecture? No, we had a circuit that looks like that. Shaheen, do you remember? Do you remember, Father?
I forget it.
Forgot? I'm gonna open it for you. So you see, whatever we take in this class, we are talking about this circuit. To download it. We will show it in a second. It is this problem. It's the same. Okay? I'm not going to solve it. Now again, now this is becoming a kid's problem for you now. 3.3 negative feedback, so what's the voltage drop here? Minus 3.3. You know that the whole current will go here, so V output is what? 3 times 2. Plus 6 minus 3.3. It's tricky. Which is what? 9.3. Question 15. Question 15. Oh, it's B. We did a mistake. Let's see why it's B. We made a mistake. What a shame. It's okay. Well, V output is what? 6. What's the voltage here? Minus 3. So 6 minus 3 is 9.3.
9.3.
Yeah, and then you bring it to the right. That's why we have to do a KVL. So it's going to be plus V output. Plus V output plus 6 times 2. 2 milli times 6 kilo. Minus 3.3 equals 0. So what's V output? Minus 9.3 volts. Get it?
Yes.
Okay, don't forget to move it to the right, okay? How about this? This is it looks like a positive non-inverting with a gain of 1 because R2 is 0. If you do it, Then the output is what? It's 5 omega t plus 20. So 16C. Quickly, without doing circuit analysis. 16C. C.
16.
It's A. We made another mistake. Why? Okay. Must be tricky. You can't solve it like that. You have to do the circuit analysis. What time is it?
Yeah, 7.
Why did they leave? 10 minutes. Was it this? Okay.
Because you have a sign at the beginning.
Minus 90.
Minus 90 is.
Well, we said C, why was it B or A? A, why it was A?
Because at the source at the question is a sign. We convert it to cosine.
Doesn't matter, but 20 minus 90 is minus 70. So, oh, there is a 5 here. I forgot the 5. Yeah. Please. صحح لي يعني.
ما شفتها.
ما شفنا الخمسة يا رجل احفلنا. أنا أقول يعني ما هو غبي دكتور بيشيل الخمسة. Well, it is A. Or it is 5 sine omega t plus 20. Basically, the concept is right. This is a non-inverting with a unity gain. Watch the videos. R2, if R2 was here, then it's 1 plus R2 over R1. Because R2 is 0, it's a unity gain. Positive. ما شفنا الخمسة اللي هنا. فكرناها نفسها. لكن it is 5 sine omega, which is 5 cosine omega t minus 70. That's why I tell you, always solve it, and then pick a question. Okay? And then here we talk about integrators. We haven't covered it yet. I think this is a differentiator. But you can see how op-amps are probably 30 to 40% of the exam. The quiz next week will be from today's lecture. Okay? Get it? I think with that, we're going to make it an easy lecture for you. We have 10 more minutes. So let's stop here from the exam. Let's cover very few concepts before we leave. We still have Thursday, by the way. And we are good in terms of the syllabus. Yeah, we're very good. Okay? So, last time we talked about the saturated input. And when did we say it becomes saturated? If you have a positive feedback, right? So the positive feedback, the output becomes quickly saturated at either plus VCC or minus VCC. If you do circuit analysis, for example, if you do this example, the op-amp shown is ideal, except, so now we haven't seen positive feedback in 3 exams. So the chances it will come in this exam is very low. Okay? Okay? So maybe it will not come. YouTube. Maybe it will come. What is I1? 2 volt minus Vx. What is Vx?
0.
Negative feedback, so it's 0. 2 minus 0 is? 2 minus, oh no.
Dictator,
No,
positive.
It's a positive feedback, so this is not a virtual summing point. So the V plus and V negative, they are not equal. So we call this what? Vx. So it is 2 minus Vx over 10k, which is equal to I2, which is Vx minus V output over 20k. So 2 minus Vx over 10k equal Vx minus V output over 20k. This is I1 equal to I2. So here, no virtual summing point, VSP. Is it virtual? Was it virtual? No. Summing point constraint. Summing point constraint, SPC. We don't have SPC here, Mishal. Why? Because it's a positive feedback, not negative. When you solve it, You also know that when you solve it, you will have Vx 1 over 20 plus 1 over 10 equals V output 1 over 20 plus 1 over 5. So basically you will have Vx equals 0.33 V output plus 1.33. Now, what does that mean? You already put 2 volts. So always you will have an output either plus 10 or minus 10, regardless. Okay, the supply here is what? Plus 10 and minus 10. What's going to change is Vx. If you have 10 volt, Vx will be 4.66. If you have minus 10, Vx will be minus 2. We don't know. Whatever upper limit or lower limit will catch in the positive feedback. So what we know about positive feedback, it will saturate. We don't know how much it will saturate to. And we know that Vx and Vn will play a crucial part in either going to V output or minus V output. Okay? Then we're going to talk about the design of simple amplifier. What time is it?
10 minutes.
Oh, we have 10 minutes. Any question about this example? So what we know is Vx and V output, they are related with this equation, and depending on V input, depending on V output, Vx will change. What if can Vx change V output? Yeah, it may change it. We don't know it's a crazy situation, unstable, غير مستقرة. Nobody uses it. Okay?
So Doctor, who control the output?
V input. But again, if you could have V input, depending on Vx and V output, they will have either 10 or 4.66 or minus 10 or minus 2. We don't know. It could swing, okay? And if it gets to 10, it will remain stuck. Notice that for Vx positive, the output remains stuck at its positive terminal, positive extreme. For Vx negative, the output remains stuck. So we don't know. If you provide here a positive input, it will be either 10 or minus. We don't know. Because here, you have equation of 2 variables. We don't know. Whoever catches first would impact the other. It's an unstable situation. It has to do with what goes inside the chip. Which transistors will ignite first.
Doctor, what is the practical use of
Nothing. Nobody uses it. You might damage the chip if you connect it that way. Okay?
Then we'll do it.
Hmm?
Then we'll do it.
Just to tell you that don't do it, okay? Design of simple amplifiers. So, do you remember this op-amp? Hatem. The old exam problem كان هذا short circuit, صح? Do you remember we had positive input, negative feedback? R2 was 0, remember? If R2 is 0, what's the gain? It's 1. Now, for this circuit, design a non-inverting amplifier. إيش معنى design؟ صمم. إيش معنى صمم؟ Pick a value of R1 and R2. So design an non-inverting amplifier that has a voltage gain of 10. Use ideal op-amp. So is this a positive gain or negative gain? So because it's a positive gain, we use non-inverting amplifier. Let's use this classical one. هذا كلاسيكي. The gain is 1 plus R2 over R1. So it means R2 over R1 should equal to
9.
Hatem. No, wrong. 1 plus 9 is 10. Okay, so R2 is 9 times of R1. Theoretically, you can pick any R2 and R1 such as R2 is 9 times R1. But very small resistances are not practical because the current through a resistor must be supplied by the output of the op-amp and ultimately by the power supply. So very small resistors are not good. Why they are not good?
The output
output will be from the
Hmm?
output will be supplied from the
No, that's
not from the
well. If you have very small, very small resistors here, V output over small resistor will have very high current. Okay? So if you connect a load, you will not have enough current to drive because lots of the current is consumed in the mathematical operation here. Let me repeat. If you have R2 plus R1 is very small. V output over a small number is a big current. So it will draw inside its feedback more current, which if you made it big, you can utilize it to drive the next stage. سماعات مثلا. Get it? Get it, Nakhli? Get it? Get it? Hajj, let me explain it again. Why we do not like small resistors? يعني 1 ohm, 2 ohm, 3 ohm, 10 ohm.
To make it current higher.
Because if you have the output of, let's say, 10 volt, 10 over a small resistor is a big current. So this current will go here while you need it to drive the output. So if you connect a speaker here, it will draw the current from the supply. And you are wasting current in the feedback. Why you waste the current in the feedback? Where you can achieve it with big values of resistance. But again, there is also a limit for. So here, for example, if you pick 1 ohm and 9 ohm, the output voltage is 10. 10 over 10 is what? 1 amp. KB equal IR. Most integrated circuit op-amps are not capable of such large output current, and even if they were, the load on the power supply would be unwarranted. يعني ممكن نجيب العيد. For general design with power supplies operated from the AC power line, currents up to several milliamps are okay. And how to get milliamps? You need to have kilo ohms. Remember this. If you want to have a circuit with milliamps, it's better for you to have resistors in kilo ohms. That's why in the lab you have lots of kilo ohms, because you don't want to have 1 amp or 2 amp. You want to have 1 milli, 2 milli, 5 milli, 100 milli max. Okay? Of course, for the supply, 5, 10. In battery operated equipment, we try harder to reduce the current because we have limited energy. For AC power lines, we don't care. Okay? We are worried that we might burn the chip. Always in design problems, we have infinite numbers of answers. So if you have MCQ, it's hard to give a design problem.
So say the products.
It will be very hard. So usually design problems has to be written. Okay? And good luck designing. On the other end, the other extreme, if we have 10 mega ohm or 90 mega ohm, those large resistances will not draw any current. Will not draw any current. It will be virtually like open circuit. And they will cause issues with stability, stability, they say, in humid environment. So generally, what should you pick? Between 100 ohm to 1000 kilo ohm or 1 mega are good design values, okay? For the summer, now this example is not completely required, but do you remember this circuit? Where we have 5V1 minus 2V2, I think we had it 4V1 minus 2. Here we have it. So do you remember this equation? Minus RF over RA, minus RF over RB. So in the design, maybe if you pick this, maybe 4K, no. RF over RA is 5, so let's say RF is 10K. RA is what? 2. RF is 10, RB is 5 kilo. It's a good design. Get it? Let me repeat. To get the 5, we want to have between 100 ohm to 1 meg. So let's pick kilo. So RF is 10 kilo. 10 kilo over 2 kilo, you get 5. And 10 kilo over 5 kilo, you get 2. Okay? We first pass V1 through inverting amplifier, the output of this inverter and V2 are then applied this one. Now, remember, in this, we have a problem. You need to have VA negative to get this is positive. Because you will always have this as a negative number. So this is inverting and this is inverting. What's the solution?
Flip the button.
Our favorite one. Do you remember the box? So here input 2, here input 1. Here we put inverting, op amp, here we use summer. Yes.
Why don't we just flip the batteries? Make,
This is not a battery, this could be your microphone. If you flip the microphone, you're gonna add an unnecessary shift.
Makes sense.
Get it? This could be a pressure signal. This could be a battery. Why you're asking the user to flip? Why you not be smart enough and expect the user to connect it in a certain way? When you develop a product, Hatim, when you develop a product, you can't tell the people to invert stuff. Okay? It has to be easy to use, not easy to use. So the solution is to use inverting and non-inverting. We did solve this, right? The final equations R2, RF, R1, RA, RF, RB, you design them in such a way. The last thing I want to talk about, can you give me 1 minute or 2 minutes? I have a class, okay. What's important in this slide is clipping. So if you, and it's basically the one sheet I already told you, if the output is 15 and minus 15, and you cannot exceed that gain, so the maximum you can get is what? 15. So we end up having what we call clipping. So make sure always the output should not exceed the supply. We will talk about this in the next lecture. Any question?